Hello friends, today we are going to complete the fundamental of statics introductory part in which we are going to learn about force, characteristics of force, transmissibility rule for the force, resultant and equilibrant of the force system, free body diagram and system of forces. So let us going ahead for the definition of force first. It is defined as the external agency or external effect which can produce or tends to produce. It means it can be producing the motion, destroy or tends to destroy, or the changing in the direction of motion. Then that external agency is known as the force, and we know that force is a vector quantity having the magnitude and direction. So second point is characteristics of forces. And so for any force it must have the magnitude, it means the value, direction, it means in which direction, either in positive or negative or any other direction. Nature of the force, it means it is pull of the force or push of the force, or in other way it is tensile or compressive. And last one is point of application, it means at which point the force is applied. So these property must be known for any force system to analyze the given body. Now going ahead for the third point as a now transmissibility means within a given body or elastic body, the point of application of any force can be transmitted anywhere along its line of action of the force without changing the effect on it. Now, as per the definition of resultant, it is a single force which produces the same effect that as produced by the number of force when acting together on the body. For example, if a body having numbers of forces like F1, F2, F3, F4 and so on, and after the application of this force, if this block is going to move in the direction of x with distance d, and if this same block is going to have the distance d with a single force which is known as the resultant R, then the both the system is equal and this single force which replaces all the forces is known as the resultant. Now going ahead for the next point as a equilibrant. According to the definition, equilibrant is a single force which, when acting with all other forces, kept the body at rest or in equilibrium. And taking the same example of resultant, if number of forces acting as if F1, F2, F3, F4, and according to definition, this body must be in equilibrium, and the equilibrant is applied along with the force, then for nullifying the effect as a distance d moved by the block, we have to apply opposite force, and if it is noted as capital E, then this single force through which this body is going to be in equilibrium is known as the equilibrant. And observing the figure, we can say that the resultant and equilibrant is equal but opposite in the nature. In simple way, resultant replaces all the forces with the same effect, and equilibrant is a replacement of result to make the body in the equilibrium. Now the next point is free body diagram. Free body diagram is an isolated view or a simplest view of any body representing all the forces acting on it with its magnitude, and magnitude is either known or unknown, but its direction must be a known. So let us taking an example as if a heavy body having the number of forces like 1, 2, 3, 4 and 5, and line of action of all the forces is concentric at one point, then the free body diagram having the value of the force as well as the direction. It means if this point is represented by the axis, then F1 in the free body diagram indicating the value of F1, but the direction is same as the application of the F1 force applied on the body. So F1, now the direction of F2 is horizontal. Now direction of F3 is in the downward direction, but parallel to this direction, if we plot a F3 over here, F4 is horizontal and F5 is in downward direction, and if we plot it like this, then the simplest view of this complicated body is known as the free body diagram, in which the direction of all the forces are there, but if we do not know the value of the force, then it is okay, which can be calculated by different equations like parallelogram, triangle, law of polygon, etc. Now going ahead for the next point as a system of forces. There are 4 types of systems available for the different types of force combination. First one is coplanar force. The definition says that all the forces must lie within same given plane. For example, xy, yz or zx, which is known as coplanar force. So if we have any body, then the force is acting along the single face of any part of this body is known as coplanar. For example, if we take this front plane, then the force is acting on this plane is known as the coplanar force system. Now second system is concurrent force system, in which all the forces must act at single point. It means if on this body, if we apply a force on this point known as a y point, then the forces on this point is known as the concurrent forces. And the third system is collinear force system, in which all the forces having same line of action. It means the all forces is on one single line. For example, if we take a forces on the single line, then all the pull and push forces is known as the collinear forces. Combination of force system is there like coplanar, non-concurrent, coplanar, non-collinear, non-coplanar, concurrent, etc. And the next system of force is parallel force system, in which all the forces line of action must not intersect with each other, or we can say that it must be at the same distance throughout the application. Like if all the forces having the distance as a d, e or f throughout the application of load or line of action do not intersect with each other, then this system is known as the parallel system. Now observing all these force which having the line of action in upward direction, so this system is known as like parallel force system. And if a force having the opposite direction of the other forces, then this system is known as the unlike parallel force system. So these are the primary requirement for the statics of given body, or we can say that the requirement of analysis of force system. Thank you.